So multiplying polynomials. If we're talking about factors, it's going to have to come up sooner or later. Multiplying a whole bunch of polynomials is really tedious, right? Like if I want to multiply these three polynomials, let's see, I have to multiply two of them and then multiply by the third. I'm going to choose those two first because multiplying binomials is easier. Right, just less to keep track of. 2x minus 3 times x minus 1 is, we'll have a 2x squared minus 2x minus 3x plus 3. So 2x squared minus 5x plus 3. And then for the trinomial times trinomial bit, I'm going to use the area method. So down the side, I've got my 2x squared minus 5x plus 3. And across the top, I've got my 3x squared plus 4x plus 5. 2x squared times 3x squared, we've got 6x to the 4th. Here we've got 8x to the 3rd, 10x squared, negative 15x to the 3rd, negative 20x squared, negative 25x, 9x squared, 12x, and 15. So combining all the like terms, we get that 2x minus 3 times 3x squared plus 4x plus 5 times x minus 1 is 6x to the 4th. 8x to the 3rd minus 15x to the 3rd, that'll actually be a negative 7x to the 3rd. 10x squared minus 20x squared plus 9x squared is minus x squared. Negative 25x plus 12x is negative 13x, and then plus 15. Okay, so that's a pain. Is there an easier way to do that? Well, no, not really. Not if we actually want to find out what they actually multiply to. So, the title of this video is a little bit of an overstatement. Getting the middle terms is hard, because we've got to combine like terms to get them. But the first and last terms, those are easy. So here, we only had one x squared term. We only had one constant. Here again, only one x to the 4th term. Only one constant. How did we end up getting those? Well, let's have some vocabulary to talk about it. Let's remember that first term is called the leading term. It has the highest degree. And then that last term is called the constant. It has no variables at all. So when we got the leading term, well, we ended up with 6x to the 4th. We got that by taking the 3x squared times the 2x squared, but we got that by multiplying these together. So 2x times x. To get the leading term of the product, we multiplied the leading terms of all the factors. And then the constant, that was the 15, we got the 15 by taking, well, this 5 and multiplying it by this 3, but we got that by multiplying the -3 times the -1. So to get the constant, we multiplied together all the constants from the factors. So getting the middle terms in a product is still hard. But if we just want to know the leading term and the constant term, that's easy. So here's a multiplication problem that we don't really want to do. But to find the leading term, well, the leading terms of our factors are these 4. Right? So we've got a 2x times a 3x times an x times an x squared. So we've got 1, 2, 3, 4, 5 x's. So we'll have an x to the 5th. And then 2 times 3 is 6, and there are no more coefficients. So that's going to be a 6. The leading term of the product is 6x to the 5th. The constant term of our product, well, we want to look at this -5, this 4, this -3, and this 5. We've got -5 times 4 times -3 times another 5. That multiplication looks like a job for a calculator. It gives us 300. So the constant term is 300. This is pretty neat, actually. Now, you might be thinking, okay, but we're not really doing the multiplication. It turns out that a lot of the time, knowing the leading term and knowing the constant is going to be enough. Furthermore, being able to go from the factors to the leading term and the constant easily is going to be really useful to us in narrowing down what the factors might actually be.